Y'all, it's Miss Johnson. Just kidding, it's Miss Power. What up? Here to make videos for the end of the year, the semester 2 final reviews. This is module 9. So we did way back in January, and I'm just going to get to it. I'm going to spend a lot of time on this first question and one of the later questions because they're the most like the ones on the test. And then I'll kind of zip through the rest of them just so you can see them if you want them. All right, this first one though is the one that's worth knowing. For number 1, we were given a filled out Venn diagram, and they wanted us to fill out a tree diagram and a two-way table. All right, for the tree diagram, okay, so what they told us is that we've got 700 plus 600 ninth graders. Both of these populations are ninth graders, right? Because they're in the ninth grade circle. They told us that we have 600 and then 450 more kids that like burgers. Everyone that doesn't like a burger, we label burgers as orange, ninth graders as maroon. Everyone that doesn't like burgers likes pizza in this, whatever environment. And then everyone who's not a ninth grader, let me make that a different color. Let's make it blue. Everyone who's not a ninth grader is an 11th grader. So these people are 11th graders. Given this, we can fill in our tree diagram and our two-way table. Let's do the two-way table first. We're looking for people here who are both ninth graders and who prefer burgers. That is the 600 people, which are both in the ninth grade circle and in the burger circle. Okay, here we're looking for ninth graders who don't like burgers but do like pizza. That's the 700 people that are in the circle for ninth graders, but not in the burger circle. A big thing here is none of these numbers are totals. None of these numbers are totals. We're going to find the totals. All right, here, these are 11th grade burger enjoyers. So inside of burger circle, outside of ninth grade circle. So that's this 450. And then here are pizza 11th graders, which is the 750 people over here in the corner that always get forgotten about, that are not ninth graders and don't like burgers. All right, now we get out a calculator, aka, your phone usually. And we're going to add these up. So total ninth graders is 600 plus 700. So that's 1300. So 11th graders is 450 plus 750, which is 1200, which makes the total people, adding these two together, 2500. We can now add up everyone that likes burgers and everyone that likes pizza. And then when we add those two numbers together, we also get 2500, which is good. It means we didn't mess up. All right. For the tree diagram, the way the tree diagram works out is we put everyone here. That's just like everyone we've got. Then we split them into two groups. We can either immediately split them into 11th and 9th grade, and then later split them up into burgers and pizzas, or we can immediately split them into burgers and pizzas, and then later split them into 11th and 9th grade. I'm going to go by age first. I'm going to put 9th graders at the top, 11th graders at the bottom. I'm going to say that there are 1,300 9th graders and that there are 1,200 11th graders. Now that I've split them up into these two groups, I'm going to further split them up into burgers and pizza. Burgers and that's not a P. Pizza. So right here are my burger-loving ninth graders, which is the 600 ninth graders who like burgers. Here are my ninth grade pizzas. Here are my 11th grade burgers. And here are my 11th grade pizzas. Nice. So now we've got all the data organized into different ways, right? We organize it into a tree diagram, a Venn diagram, a two-way table. Now that it's organized, in whichever way you like the best, we can come down here and answer some questions. I prefer the two-way table, so I've made it so we can still see our two-way table. Okay, find the following probabilities. All of these are going to be fractions. You can do the actual division and get a decimal for these fractions. You don't need to. I don't actually care. But if they ever ask you for the percent, you will do the decimal. Okay, the following probabilities. This just means the percent or the probability that a student, a random student, likes pizza. So what we're going to do is we're going to put everyone total that loves pizza on top. We're going to put everyone total, just the total of everyone on bottom. That's it. All right. Number, whatever this is, 1, 2, 3, 4, 5, 6. 6 is similar, right? This one where it just says probability of 11th graders, I will put the total 11th graders over the total students. All right, those are the easy ones. Now we're going to do the ones that say and. This symbol means and, right? It means that both of the descriptions need to be true. So when I say what's the probability of liking pizza and being a ninth grader, it means only these people are enough to satisfy me, right? They have to be both in ninth grade and like pizza. So I'm talking about specifically, another thing people like to say here is it's specific. Specifically, those 700 people. But I'm still talking about them as a total of the entire group. All right. For number 7 over here, this is ninth grader and 11th grader. How many people are in both ninth grade and 11th grade at the same time? You got it. There is no one in both of those grades at the same time. So this would be 0 out of 2,500. Okay. The next one we're going to go with is or. Or is the U looking thing. It's called a union. This means we are cool with either of these descriptors being met. I'm cool with, so in number 4, where it says probability of a burger or 11th grader, I am cool with this person because they're burger people who like 11th or are in 11th grade. Great. I'm also cool with these people because they like burgers. It's okay if they're not 11th graders as long as they're burger lovers. I'm also okay with these people. It's okay that they don't like burgers because they are in 11th grade. Everything that I just circled in green is either a burger or an 11th grader. And it's okay if it's both. So what I'm going to do here is I'm going to add those numbers up. 600 plus 450 plus 750. We're going to make that black so you can actually see it. Ooh, no, we're just going to over here. And again, this is over the total population. Then we would get out our calculator and actually do this addition up front. So 600 plus 450 plus 750 is 1,800. There are faster ways to do that calculation. We could add up these two and subtract this one so we're not adding it twice. We could do this minus this because it's the only one we don't care about. But to be honest, I just like adding the 3 up to make sure I do it right. Same thing here. For number 8, what's the probability that we are pizza or 11th grade? I'm going to add up all the pizza people. So that's 700 plus 750. And then I'll add the other people who are in 11th grade. Put that over 2,500. Get a calculator out. And get that this is 1,900. Cool. The very last one, which is kind of wacky for a bunch of people, is this bar thing, this line in the middle of our sentence. This line means given that. Let me type that out. Given that. It's basically shrinking our population size. I don't want to be talking about all 2,500 students anymore. I just want to be talking about a specific subset of that population. For instance, here in number 3, I only want to be talking about ninth graders. So instead of looking at everyone, now I'm only looking at these people, and I'm saying what percentage of ninth graders like pizza? Or what's the probability that a ninth grader likes pizza? So the total will now be total ninth graders. and the numerator will be all of the ninth graders that like pizza. Same thing here when we're doing percentage of 11th graders who like burgers. We read this as what's the probability that you like burgers given that you're in 11th grade? Well, there's only 1,200 11th graders, and only 450 of them like burgers. Okay, that's the one main question I want to get over. The other main one is this is good practice if you want more practice with the probability stuff. This is good practice if you want more practice reading a Venn diagram. This, I'm not gonna lie, this is just kind of fun for me. This one, this is the other one I want to talk about. And then these ones, yeah, this is the other one I want to talk about. So in this first one, we were given all of our information in a Venn diagram, and we moved it to other types. In this one, we're given our information in a lot of different places, and we want to, sorry, let me move this, and we want to compile all of these into one. I'm going to use the two-way table as kind of my home base and move everything here and then like disseminate afterwards. So we are given this piece of information that 40% of all people like American Idol, or all people surveyed. We are given this piece of information that of the males and females surveyed, 255 of the males liked The Voice. And again, I'll describe how we figured that out as well. And then over here, we were given the information of the females and males surveyed. 355 of the females liked American Idol best. So let's put all those together. This one first, because I think it's easiest. This is describing males because it's inside of the male circle, and it's describing The Voice because we're saying that The Voice and American Idol are opposites, and this is not in the American Idol circle. So I can go ahead and put 255 right here. Almost looks like a 5. Oh, over here, this is females who like American Idol. So we can just put in 355 here. And then the last piece of information is this 40% of all people liked American Idol best. We know that all people is 1,500. So off to the side, we can do 1,500 times 0.4 for 40%. 1,500. And we get that 600 people total like American Idol. Okay, again, I'm going to do my home base first, and then I'm going to go for the rest of the information. In my home base, I know that American Idol total plus The Voice total equals the total. So I know that 900 people must have liked The Voice because they did 1,500 minus 600. Now, I can get this one by doing 900 minus 255. 900 minus 255 gives me 645. Now I can get this one because I can do 645 plus 355. 645 plus 355 equals 1,000. 1,000. This plus 1,000 needs to be 1,500, so this must have been 500, making this 245. And then we can check to make sure all of our rows and all of our columns add up to the same thing, which pretty sure they do. So there you go. Nice. Now that my 2-way table is finished, I'm going to fill in my Venn diagram and fill in my tree, like my tree. For the Venn diagram, this middle part is in the male circle and in the American Idol circle. So this must be males that liked American Idol. This is in the American Idol circle, but not in the male circle, which means this is going to be 645. And then outside of all of these circles is the female Voice fans, which are, oh shoot. Oh, no, female American Idol is 355. Don't let me lie, y'all. 355. There we go. And then out here is the female voice people who like, who are females who like the voice. Great. Over here, this is where we put the total males, which is 500. This is where we put total females, 1,000. I like putting the total of everyone here. I'm not sure it's necessary, but couldn't hurt. This is male The Voice and male American Idol. And this is female The Voice and female American Idol. Cool. Then over here, we've got some questions. We want to find more probabilities. This is the probability of what's the probability that you like The Voice given that you are a female? This means we're only asking females. So we're only asking the 1,000 females. And then we're asking if they like The Voice, and 645 people say yes. Similarly down here, this is we're only asking men, and they are telling me whether they like American Idol or not. Over here, these are both and, which are the specific one. So it's only going to be one of these little boxes. We're not going to add them together. And the total is going to be everyone because there's no bar. There's none of this conditional probability. This is The Voice and men, which is this group. And this is female and American Idol, which is this group. All right, y'all, those are the two main ones I want to go over. The other thing, we didn't do an independence one. The other thing I want to do is an independence one. So let's find one of those. Here we go. Let's do this one. Students at a local high school were identifying what grade they're in, so either 9th or 10th graders, and whether they liked math or science better. We have the data on the Venn diagram, and we want to know, are being a 9th grader and liking science independent of each other? Independent just means if I ask everyone if they like science, I get a certain percent back. And then if I said, no, wait, hold on, let me only ask 9th graders, if the percent is the same, then it didn't really matter whether I was talking to 9th graders or talking to everyone. That means they're independent of each other. If it did matter, if those are different percentages, then they're dependent on each other. It did matter that I asked 9th graders. So the way we check this, we ask if people like science. Then we ask only 9th graders if they like science. If these two are the same, they're independent. If these two are different, they're dependent. So let's figure this out. Oh gosh, how many people are there total? Total in this Venn diagram is 65 plus 40 plus 35 plus 25. Means we're talking to 165 students. Is that true? Yeah, that seems right. And then the total 9th graders are just these two added together. So total 9th is 75. The reason I always do the totals first is because I like to. You don't have to. Now I'm going to say how many people like science in general. Everyone outside of the math circle likes science. So these people like science, and these people like science. Wow, I wish I could spell. So total, 60 people like science, 35 plus 25. As far as 9th graders go, only 35 of them like science. Now, I'm going to do this division. 60 divided by 165 is 36% repeating. And then 35 divided by 75 is 0.46 repeating. These are not the same number, so they are dependent on each other. It did matter that we asked 9th graders versus just asking everyone. Yeah, the answer keys to all of this are posted online. If you want an explanation for some of the other ones, you can come talk to me during class or come talk to me after school on Thursday. Otherwise, I think these are the heavy hitters for the finals. Cheers.